Now I'm gonna solve this problem too, and here the question is uncompacted sand fill 6 feet in depth and relative density of 40% and the minimum and maximum void ratio is 0.46 and 0.90 and the specific gravity of solids of the sand is 2.65. The question is determine dry unit weight of the sand. Okay, given that minimum void ratio is 0.46 and maximum void ratio is 0.90 and specific gravity is 2.65. We know the formula of dry unit weight is specific gravity into water unit weight divided by 1 plus void ratio. Now we have to find the value of void ratio. So we know relative density equals to max void ratio minus void ratio divided by max void ratio minus minimum void ratio. Relative density is 40%, which means 0.4. Max void ratio is 0.9. Minimum void ratio is 0.46. So, void ratio will 0.724. Now, dry unit weight will 95.92 pound per feet cube. And the next question is, if the sand is compacted to a relative density of 75%, what is the decrease in thickness of 6 feet fill? Our uncompacted sand was fill 6 feet in depth and there has relative density of 40%. Now compacted to a relative density is 75%. So the question is, what is the decrease in thickness of 6 feet fill? Okay, we know dry unit weight into volume equals to dry unit weight into volume. This is the weight for uncompacted situation and this is the weight for compacted situation. For uncompacted situation, dry unit weight is 95.92, but we don't know the value of dry unit weight after compaction. Now we should find the value of dry unit weight after compaction. We know dry unit weight equals to specific gravity into water unit weight divided by 1 plus void ratio. But we don't know the value of void ratio after compaction. So first we have to calculate the void ratio after compaction. We know relative density equals to void ratio max minus void ratio divided by void ratio max minus minimum void ratio. Here the compacted relative density is 75%, which means 0.75, and we know max void ratio is 0.9, and minimum void ratio is 0.46. This void ratio is for after compaction. So void ratio will 0.57 and dry unit weight will water unit weight for pound per feet cube 62.4 and void ratio after compaction which is 0.57. So dry unit weight after compaction is 105.32. Now we get dry unit weight after compaction. So volume means area into thickness. This thickness is for uncompacted situation and this thickness is for after compaction. And the question is determine the thickness for compacted situation. So dry unit weight for uncompacted situation is 95.92 and the area for compacted and uncompacted situation is same. So I can remove area from both sides. And uncompacted situation thickness was 6 and after compaction we get dry unit weight is 105.32 and this is thickness after compaction. So after compaction thickness will 5.46 feet and the question was what is the decrease in thickness. So thickness decreases 0.54 feet. Okay, thanks for watching my video.